Estimating the real-world distance between moving objects in real-time video. Step number 1. First, calibrate the camera to estimate the camera parameters of the lens and the image sensor using chessboard. As you can see here, I already used this chessboard to take these pictures and calibrated my camera using MATLAB application. And I get these parameters regarding to my own camera: the focal length, the principal point, and the image size. As you can see here, this is the code regarding to calibrating my camera for taking these parameters, for getting these parameters. And the second step is using my calibrated front-facing camera to record a short video of a different moving objects, which used for object tracking and detection. And I already read the short video, which already taken from my camera, and start detecting the object. Step number 3, detecting the foreground objects and displaying the result like this figure. And using the background subtraction algorithm, and we notice that the segmentation process is going accurately. Detect objects function return the centroid and bounding boxes of the detected object. As you can see here, every single object, single moving object has now ID or bounding box, and return the binary mask. As you can see here, the object and the foreground object has a value of 1 white color, and the foreground non-detected object, it has value of 0 black color as a foreground. And make sure that the object in the input images or the input video is the same size as this picture, or after applying a binary mask. Step number 4, initialize the tracking by creating an array of tracks where each track is structure representing moving objects in the video. We are now starting tracks, as you can see here in the code. And we can now start tracking across video frames. Video frames means that different pictures a long time. And maintain a state that tracks object using here the ID segmentation. We still had the ID boxes around the object over all the video. And as you can see here, we use the Kalman filter to predict the centroid, the center of each object tracked in the current frame, and update the bounding box accordingly. We use it, and after that, we update the bounding box according to the moving of the objects. After updating the assigned tracks, we supposed to predict a new location, then update the assigned track, update, then predict the new location, and measuring the distance between the object through the different frames. As you can see here, I already used different object, and now we can see that the difference between these objects. And as you can see here also, the sizes of the object is still the same size of the beginning, and as you can see also, every single detected object still have its own bounding box or ID. That's it, and thank you for your watch.